Alright, so today we're learning lessons 7-1 and 7-7. Please do not answer my questions just because we're videotaping. It's okay. Your class is the only one that hears this. Got it? Okay, 7-1 and 7-7. So the first blank is a ratio. A ratio is a comparison of two things using division. We can write this in three different ways. So if we're just using, for example, ratio A and ratio B, we can write it three different ways. Here's number one. We can write it as A to B. You can write it as A colon B. That's the second way. Or the third way, we can write it as A over B. But in any of these instances, B cannot be equal to 0. Why do you think that is? What is A over 0? Undefined. Friends, don't let friends divide by 0. That's why B cannot be 0 in any of these. Because if you plugged it into number 3, A divided by 0 is undefined. Ratios are expressed in simplest form. So you need to reduce every time. Simplest form. Now, if you are comparing more than two things, it's called an extended ratio. So that is if you're comparing 3 or more things. So this is how you would write it. 3 to 4 to 5. So this is just an example. So if we're using this extended ratio 3 to 4 to 5, that means the ratio of the first two terms are 3 over 4. So the first two are 3 over 4 and 3 over 4. The ratio of the last two are 4 over 5 and 4 over 5. And the ratio of the first and last is 3 over 5. So this is an example using numbers. I want to actually tell you how it will look in terms of A, B, and C. So if you have, instead of 3, 4, 5, you have A to B to C. The first two quantities would be what? Using this example I just gave you. The first two here are 3 over 4. What's the first two here? A over B. Okay. Last two will be what? B over C. And the first and last are A over C. Alright, so that's really all you need to know, notes-wise. From here on, we're just doing examples of how to use all of this. So in example number 1, Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-teacher ratio at his school? So if we're going to use A to B, we can use A over B. But we need to use it in the form that it gives it to us. So which comes first, student or teacher? So student goes on top and teacher goes on bottom. Okay, so fill those in. We know there are 2,650 students for every 190 students. Teachers, sorry, yeah. So there's 190 teachers, 2,600 students. Now, I want to find how many students there are for every one teacher. So if you just divide this, 2,650 divided by 190, it is approximately, do y'all know that means approximately? 13.95. Good. Approximately 13.95 students for every how many teachers? 1 teacher. But I don't want to have 95 hundredths of a student. So is that close enough to round up and we can say there are 14 students for every 1 teacher? Yes. So that's what we would do. We would say 14 to 1. I can write this 2 more ways. What's one of them? To the word and 14 colon. So you could say 14 over 1, 14 colon 1, or 14 to 1. So at any time when what I'm about to write goes with example 1 and 2, so if you don't have enough room you can write it for 2. When you have a ratio in which the denominator is 1, it's called a unit rate. So whenever the denominator is 1, it's called a unit rate. Alright, so number 2, talking about a baseball player. Any baseball players in here? Out of the 6 males we have in here? Any softball players? Oh yeah, we do. Alright, so let's find the batting average of one of the Minnesota Twins players. So a baseball player's batting average is the ratio of the number of base hits to the number of at-bats. So if we're taking the ratio of this right here, number of base hits to number of at-bats, which one comes first is the base hits. So that one goes on top. So base hits goes on top. Over the number of at-bats. And I put it in that order because that's the order it gave me.
Ms. Jenkins, we need Haley Brown to check out, please.
Okay. Haley, that half sheet I gave you is y'all's homework. Okay, so if this person had 521 at-bats, so it goes on bottom, and 181 hits, let's find the batting average. So 181 divided by 521 is approximately 0.347 over 1. Is this a unit rate? Yes, because it's over what? 1. So, in conclusion, Mauer's batting average. Now, baseball, they do use it as a 0 point something something. So, you can leave it as that. So, his batting average was 0.347. Yes?
Is that a typo? Well, it says 3006, or what is it?
No, I don't know. It could have said 2006, or somebody could have been futuristic, thinking of the future. All right, next. What kind of ratio is this? What kind of ratio? Extended, because it's more than 2. It's 3 or more. So, here is our triangle. Here's a triangle. And I know the measure of the angles is 3 to 4 to 5. How much does a triangle equal? 180. So I can write this, because it's the ratio 3 to 4 to 5. We can write this to figure out which one each angle is as 3x, 4x, and 5x. Now, if I wanted to find what x is, to plug it back in and find each of these individual angles, I would set all of these equal to 180. 3x plus 4x plus 5x is equal to 180. I got 12. 12x is equal to 180. Oh, okay. X was equal to 15. So x is equal to 15. That's not what I was looking for, though. Find the measures of the angles. So the first one is going to be 3 times 15, which is 45. Second one is going to be 4 times 15, which is 60. The second one is 5 times 15, which is 75. So to check, you could say, well, do these add up to equal 180? And yes, they do. So it's good. All right, number 4. In a triangle, the ratio of the measures of the sides is 2 to 2 to 3. Yeah.
So that's
That's it. Yeah. You're just finding all the different measures. And the perimeter is 392 inches. So remember, when you're finding the perimeter of a triangle, you're taking all 3 of the sides and adding them together. Well, I know that these 2 are both the same. So instead of just writing 2, I can write 2x, 2x. And this third one is 3x. So to find what each length is, I'm finding the perimeter, so I'm just going to add all 3 of these together and set them equal to the perimeter, which is 392. So 2x plus 2x plus 3x is equal to 392. Oh, I got 56. I'm sorry. 56. Which should give you 112 inches. Remember what you're talking about. 112 inches and 168 inches. So those are the lengths of all 3 of the sides. If you want to check, just to be sure, if I added these up, what's must they have equaled? 392. All right, to the back. An equation stating 2 ratios are equivalent is a proportion. So when you're setting up a proportion, you're saying that they are equal to each other. Okay, in this case, A and D are your extremes. That's their names. Just the name they have. So A and D are extremes. C and B are called mean. Extreme and means. So when you're taking the cross product in a proportion, the product of the extremes, which is A and D, must be equal to the product of the means, which is C and B. So when you cross multiply, your extremes, AD, must be equal to B times C. B cannot be 0, D cannot be 0. Why?
Because they're denominators.
They're denominators. If 0 is in the denominator, it's undefined. Okay, these are just some little practice problems to practice cross multiplying. Remember, you take multiply x and -6, so you get -6x equals 4 times 11 is 44. Leave it as a simplest form fraction. So when you divide by -6, you get negative, leave it as a fraction, 22 over 3. I'm okay with you not leaving it as a fraction if it is a quarter or a half or 3/4. But if it's something that keeps repeating, then I need you to leave it as a fraction. I just divided both of them by 2. Alright, another cross multiplying. When you have more than one thing on the bottom, if it helps you put parentheses around it. That way when you multiply, you know that you have to put these parentheses and distribute. So we get 8x plus 20 equals 6 times 7 is 42. So,
Ms. Jenkins, can we have Joe Ford to check out, please?
yes, ma'am.
Thank you.
So x is equal to 2.75. Or 2 3/4. Are we good to skip number 7? Okay, if you need more practice, go back to number 7 and practice. Let's go on to number 8. If the ratio of boys to girls at a high school, so which one comes first? Boys to girls. So the ratio is 4 to 3. Bye, JoJo. That half sheet's your homework, okay? And there are 936 boys, so that goes on top because boys are on top. How many girls are there? So you can put anything. You can put any letter. X, A, G, B. So in order to find how many girls there are, set a proportion because they must be equal to each other. So if I cross multiply, you get 4x is equal to 2,808. Divide by 4. So there are 702 girls. Don't forget to put what we're talking about. Don't just leave it as 702. Tell me what we're talking about. All right, this right here is getting into 7.7. So all we just did was 7.1, and this is 7.7. A scale factor is next. It is a unitless ratio in simplest form. Always write the length of the model first in the ratio, and then write the actual. So you will always have the model first, and then whatever it actually is. So y'all know this city project that one of my geometry students did? Okay, we're looking at this. This is the model, right? But if I actually wanted to find out the dimensions of this city, it would be the actual. So model is this, but actual would be the actual city. So on number 9, we have that the miniature replica, so is that the model or actual? Model, because it's the miniature replica. So this is the model of a 1923 checker cab is 6.5 inches. The actual length of the car was 13 feet. So what's the scale factor? Well, the model goes first. So I'm going to write 6.5 inches over the actual, which was 13 feet. So we need to simplify this. It simplifies to say for every 1 inch in the model, in real life, it is 2 feet. So the scale factor of the model is 1 inch for every 2 feet.
I'm confused with how you got 1 inch and 2 feet because
I just simplified this, 6.5 over 13.
So you just divided it.
Mm.
But doesn't it have to be the same unit before you produce the fraction?
Mm-mm. These will never be the same unit because we're talking about they're 2 different units. So it's a unitless ratio. Yes, Kara. I just divided 6.5 over 13. And you get 0.5, which is 1/2.
So 1/2, can you just do 1 inch?
Yeah, so for every 1 inch in this replica, it's 2 feet in real life. Okay, so back in the old days, we used these things called maps. And you can't really put a real city on a map, can you? No. But can you use a scale factor and say for every 1 inch, this is equal to 50 miles, or this is equal to 25 miles. So that's what's going on in number 10. If a map scale is 1 inch for every 50 miles, so this is the model or actual? 1 inch is the model, and the actual is 50 feet. So for every 1 inch, it stands for 50 miles. Well, in between point A and point B is 3.5 inches. So I want to know, if I'm traveling 3.5 inches between A and B, how many miles am I actually moving? So cross multiply, 1x, which is really just x, is equal to 175 miles. So in between point A and point B is 3.5 inches. Well, yes, but how many miles am I actually going to drive? 175.
Wait, Michigan, I still don't get how you got the 2 feet.
I just took the calculator and did 6.5 divided by 13, and I get 0.5, which is the same thing as 1/2. So if it was 2 inches for every 4 feet, I could reduce that to 1/2. If it was 6/9, I could reduce that to 2/3. Okay, so for tonight, we're moving quick this week because we're covering so many lessons. This is your homework. Do not do this on this piece of paper. Do this on a separate piece of paper. I am taking it up tomorrow. Yes?
How did you find x?